The problem with two-way and intermediate switching. Your phone rang this week. Homeowner, staircase light, just wanted a new switch. They turned off the power, pulled off the old faceplate, and that was the last confident decision they made. Now it's your job to untangle what optimism and panic left behind. Here's how it always goes. They move in, decide the switch plates look tired, buy something brushed steel, matte black, screwless, something that says interior design rather than 1997 new build estate. They watch a YouTube video, turn off the power, and then they pull off the faceplate. There are more wires than expected, a lot more wires. The colours don't match the YouTube video. There's brown, black, grey, blue, maybe old red and black with a sleeve shoved on the earth. Some conductors are sleeved, some are not. The terminals on the new switch are in completely different places to the old one. At this point, the sensible ones stop and call you. The brave ones crack on. And by brave, I mean they pull every conductor out, forget exactly where it went, fit the new switch using optimism and panic, and then discover the upstairs light won't turn off, the downstairs light won't turn on, and the landing switch now appears to be controlling the emotional state of the whole house. Then they call you. That back box isn't a wiring accessory anymore, it's a small electrical crime scene. And here's the thing, this isn't entirely the homeowner's fault. Yes, they shouldn't have started. But the reason it's so confusing is that traditional two-way and intermediate switching hides genuine complexity behind what looks like a simple switch plate. On paper, it's elegant. Two-way switches at each end, intermediates in the middle, strappers connecting the lot. In a back box, especially after someone's been in there, it can look like the inside of a 1980s synthesizer. The principle isn't that complicated, but the execution depends on when the house was built, which wiring method was used, whether it's loop-in or joint box, and how many electricians have been in there with different ideas before you. That's why it's such a reliable call-out generator, and it raises a genuinely good question: is there a better way? Meanwhile, across Europe, they've been quietly doing something smarter for years. Across large parts of Europe, multi-point lighting control works differently. And if you've ever stayed in a hotel in Europe, you've already used one. You walked in, hit the light switch, and heard that heavy clunk? That's a relay switching. Not mechanical contacts in the switch itself, but a relay mounted somewhere in the building doing the actual work while the switch just sends it a signal. In those installations, the switches are simple push buttons. Each one sends a control signal to the relay. The relay does the switching, add another switch position, add another push button. The relay handles the logic regardless of how many buttons are connected to it. It's beautifully boring. And in electrical installation, beautifully boring usually means easier to understand, easier to extend, and much harder for someone to scramble during a decorating session. So, perhaps it's time we had a bit of that over here. This is the Theben OKTO540. Compact enough to sit behind a standard switch plate, which means no separate enclosure, no surface mounted box, no extra fixings. It goes exactly where the switch already lives. Fully electronic, which means when you press the button, you get silence, not the hotel clunk. Zero crossing switching, LED compatible, no flicker, no hum. And this one device replaces the entire logic of your traditional two-way and intermediate switching arrangement. The wall switches don't need to do the clever bit anymore. They just become push buttons. Any of them changes the relay state. All of them work every time. Simple to install, simple to explain to a customer, and simple for the next electrician who opens that back box. But here's where the wiring gets really interesting, especially on a retrofit. With the OKTO540, every switch position is simply a push button connected back to the relay control input. That means you only need 2-core cable to each switch location from the relay. Not 3-core, 2-core. At the time of filming, a 100-metre drum of twin-and-earth from eFIXX is £50.99. A 100-metre drum of 3-core and earth, £71.99. That's a £21 saving on a single drum of cable. Before you've said a word about shorter runs, easier routing, or reduced installation time, you've already clawed back a significant chunk of the relay cost purely by not needing the more expensive cable. And you're not locked into a single wiring layout. You can wire it loop in, loop out, cable leaves the relay, goes to the first push button, loops onto the second, onto the third. Just like electricians in the UK are already used to wiring lighting circuits. Or you can go star wired. Each push button gets its own 2-core cable taken directly back to the relay. Useful when the building layout suits it, or when you want future fault finding to be as clean as possible. Or, and this is the bit worth noting, you can mix both approaches on the same installation. Some push buttons looped, others home run. The The relay doesn't care. As long as the push buttons are wired to the correct control input, they all do the same job. The principle stays identical regardless of how many switch positions you need. More positions means more push buttons, not more complexity. And when the customer changes their mind, and they always change their mind, and wants an extra switch position by a second doorway, you're not reworking a two-way and intermediate circuit. You're not wondering where to break into the strapper arrangement. You're adding a push button, loop it from a nearby position, or bring a new 2-core back to the relay. Job done. Here's a problem nobody talks about until the job gets bigger: volt drop. In a conventional two-way and intermediate circuit, the lighting load current may have to travel through the switch wiring as part of the final live path to the lamp. In a normal house, short hallway, single staircase, probably not an issue. Now think bigger. A communal staircase, block of flats, several floors, switches at every landing, lighting point at the top of the stairwell. With a traditional wiring approach, the switch live path can end up taking a very long route. The current travels from the supply through the switching arrangement, along the strappers and intermediates, through the final switch position, and then back up to the light. That can mean a long loop of cable that exists mainly because of the switching method. Longer cable, more resistance, more volt drop. Even with a modest lighting load, the route length can quietly grow into the gremlin hiding under the floorboards. With the OKTO540, that changes. The push buttons are only control devices. They're not carrying the full lighting load. The relay can be positioned close to the supply point, so the lighting load takes a short, direct route. The push button control wiring can be as long and flexible as the building requires, but it's not carrying load current. Less copper doing unnecessary travelling, less volt drop, and a layout that makes far more sense when the building grows beyond a typical hallway. There's also an advantage at the testing stage. With a conventional multi-point circuit, insulation resistance testing can get involved because the circuit path changes depending on switch position. You need to test every possible combination. 2 switches is manageable. Add intermediates across several floors and suddenly you're solving a combination lock in a stairwell. With the relay approach, control wiring is on one side. Load wiring is on the other. You test them separately. Cleaner inspection, clearer fault finding, and a circuit the next electrician can actually understand when they open it up in 10 years' time. Now, I know exactly what some of you are thinking. You're adding a component, a relay, another piece of kit in the circuit, another potential failure point, and that's a fair shout. Any additional component is one more thing that could go wrong. But let's put it in perspective. The OKTO540 is fully electronic. There are no mechanical contacts wearing out from repeated switching, no relay chatter, no mechanical noise. Press the button and the light changes state in silence. It also comes pre-wired with short connection tails, so instead of trying to get a screwdriver into a tiny terminal inside a sealed enclosure, you've got conductors ready to wire into your connection point. And it's sealed, properly sealed, which matters in the real world where switch boxes and junction boxes end up in places that see damp, condensation, or general building unpleasantness. Moisture in electrical connections is how you get leakage currents, nuisance trips, and intermittent faults that make fault finding feel like chasing a ghost around a corridor with a multimeter. A sealed electronic relay helps close that door. Traditional two-way and intermediate switching works. It has worked for decades. Nobody is suggesting you rip out every lighting circuit in the country, but when you're designing a new installation, refurbishing a property, dealing with a multi-floor communal staircase, or you simply want a switching arrangement that's easier to extend and easier to hand over, this approach starts to make a lot of sense. The next person who opens that back box is far less likely to find a fistful of mystery strappers waiting to ruin their afternoon. I'll leave a link in the description so you can find out more about the OKTO540 from Theben. Are you ready to leave the 3-core and earth switching arrangement behind, or is it staying in the van until someone physically removes it from your cold, copper-stained hands? Let me know in the comments. And one question that always comes up with this type of approach: what if the customer wants dimming as well as switching from multiple positions? The answer is in the video on screen now.